Hello, and welcome back to another REPL speedrun. Today, we'll be starting the lists challenges from 7.1 to 7.4. But before we start, we want to talk about what a list even is first. If you remember from Unit 5, we had our old friend, the string. Say the string is equal to hello world, and we can access different characters in the string from their indexes. If you remember, this is 0, 1, 2, 3, and so on. So if we get the 0th character in the string, this would be equal to H. If we want to get the 3rd character, or the character at the 3rd index really, in the string, it would be equal to L. And so, what is a list now? A list is extremely similar to the string. It's a combination of some elements. The best way to think of it is that it's a variable that stores more than one variable. For example, we have a list L here, and we always make a list using square brackets. And let's put the elements H, 2, 7, and 5 in our list. And as you can see, we separate each element using these commas over here. So commas separate elements in a list. So if we want to get this H, which has the 0th index, so they're also indexed the same, then we can go L, 0, and that will give us H. If we want to get this 2 over here, then we can get L, 1, and it's equal to 2. And if you notice, we can put both strings, numbers, and other data types in the same list, and that's because Python is special in that way. You don't need to go into too much depth about it, but you need to know that you can do it, and it will make your life a lot easier. So, the same with strings, we can also slice lists to get smaller lists inside. For example, if we want to get this H and the 2, we can go L, and then we're starting from 0, so we don't have to put anything. And we're ending at 2, because this is exclusive. Remember that the number here, we exclude the index. So this will only get the elements 0 and 1. And this will give us a new list, which has H and 2 in it. And the same as a string, we can also use the step function to skip over elements. For example, we want to get the elements 1 and 3, we can do that using L, and then we're starting at 1, so we put 1. We're ending at the end of the string, end of the list, so we don't have to put anything because 3 is at the end of the list. And we want to step over every other element, so we put 2. And this would give us a new list with the elements 2 and 5 in it. And so in that way, we can slice up lists. So when we do some actual coding, it might get a bit easier to understand. So if you're not getting it too well right now, maybe watch along until we start working with some lists. And if you need to, go back to this section. So one of the most important parts that goes with a list is our for loop, our old friend, the for loop. So right now, we've only been using the for loop in this way. For I in range, and then put a number here, say 5. But to understand how we use the for loop in lists, we also need to understand what this range thing does. And what range does is it actually gives us back a list with the numbers from 0, 1, 2, until the number right before this number we put in the brackets. So that would be 4. And every time we go through the for loop, it sets I to each of these elements, one by one, just moving along. So now What if we want to loop over a list? So if we have a list here, say it's just 1, 3, 5, and we go for I in list. Notice we're not using range anymore. We can loop over the list directly. Print I. Then this will output 1, 3, and 5. Let me just show you this in code. So let's say we have a list which is 1, 3, and 5, and we go for number in list. This will loop over each number in this list. So if we print the numbers, as you can see, we have 1, 3, and 5. And in the same way as this, we can slice this up. So we only want to get the first two elements of the list. If we print :2, it will go 1 and 3. Say we want to extend this list a little, and we want to skip every 2 elements, we can put ::2, which remember this is 0. This means the length of the list, and that means 2. This is shorthand. If we put that, it will give us 1, 5, and 9. And so now I think we're ready to start tackling these challenges. Actually, wait. There's one last thing we want to say. So, how do we get an input? Say the input, if we get an input right now, say let's just go A equals input. It's not going to be a list. It's going to be a string, right? So we can check that by using this method print is instance, which tells us what A is. And so if we compare A to a string and type in some input, as you can see, A is a string. And to be able to complete these challenges, we want to be able to convert the string input into a list. And how do we do that? Well, we're going to use this handy method called input.split. Now, what does input.split do? Imagine we have a string. A equals hello world. What input.split does, or what split does actually, because it's more of a string function. Say we do a.split, it will create a new list that's separated, so every element is separated by a space. So if you run this again, then as you can see, it split up the string into different elements in the list. In our case, it's hello and then world. And as you can see, the space is gone. And that's how we're going to convert our strings into a list. So we're given a list of numbers. We need to find and print all of its elements with even indices. And first, let's get the list in, which A equals int s. For s in input.split, note that we're converting each. Actually, we don't need to do that. We can just straight up go s for input.split in our case. And now we want to loop over this list, remembering our for loop. So for number or element in A, the thing is we only want to print elements with even indices. So we can use something called enumerate, a handy trick. And what enumerate does is the index and the element at that position. So we actually get 2 things back. Let me just show you what I mean. If A is equal to 1, 3, 5, 7, 9, and we want to print both the I and the element when we enumerate it, this will give us the index of the list and the item at the position. So as you can see, at the 0th index we have 1, at the first index we have 3, and so on. And so converting this back to s for s in input.split, we want to print every even element, and how we do that is we check if I is even. So if I modulo 2, which we know if it's divisible by 2 means it's even, we want to print the element in the list, and this should work. For example, we give a string 2, 4, 2, 3, 4, 6, 7, and run this code, it will print 2, 4, and 7 because they have the even indexes. So if we submit this code, we should see it should work. And just like that, we've got it working. Now, on to the next challenge. So, we're given a list of numbers, print all of its even elements, and we want to use a for loop that iterates over the list itself without using range. So, we can copy this, which will give us a list, and we want to check if each element is even, and if so, we want to print it. So we want to get each element in the list, and if element is even, so if element modulo 2 is 0, then we want to print the element. And it's as simple as that. So if I run this code and say let's put some random numbers, maybe some even ones now. As you can see, it only prints the numbers that are even, so if we submit this code, it should work. Now, on to the next challenge. So, given a list of numbers, we want to find and print all the elements that are greater than their left neighbor. And so what they mean is if the element is greater than the element directly to the left, or with the index of its index minus 1, we want to print it. So, I also think that we just don't consider the first element, because as you can see here, it doesn't have a left neighbor, so it can be greater than its left neighbor. So we get a list and then we take this input. We want to iterate over this list using enumerate. So for I element in list, and actually here we can slice the first element off the list because, as we know, it's not needed. So we want to compare it to the element in the list before it. So if element is greater than in the list, actually this is a very bad habit. Do not call your lists list. Just call them something other than that, because list is a reserved name in Python. We don't want to be playing around with that. It's like making a number. Just don't do it. So, anyways, if the element is greater than the element in the previous position, in this case this would be I minus 1, then we want to print that element. And say we want to run this code, let's just put the example input in, and oops, what have I done? Cannot unpack non-iterable int object. Whoopsies. I forgot to put enumerate before this list. So now, if we get our example input, and as you can, as you can see, it has not worked. So I wonder why. So if the element we have is greater than its left neighbor, I remember why. It's because we are skipping the first element. As you remember, so this should actually be I minus 2. So if we paste this, what am I doing? If we copy as input and paste it, as you can see, we get the correct answer. And so if we submit this code, as you can see, it's all working. So just remember, if you're getting errors, you want to check each line of your code. Say we forgot to put this enumerate, and look at the error it's giving you, and look at the line it's on. So see, it's on line 6, so we can look at this line over here, and as you can see that we forgot the enumerate. And after we fix all the errors, our code should run fine. Finally, let's go to the last challenge. So, given a list of non-zero integers, find and print the first adjacent pair of elements that have the same sign, and if there is no such pair, print 0. So first we want to input our list as L, and we want to loop over this list. For I element, we want to use enumerate again because we want to be accessing both the index and the element at that current position. Enumerate L, and we want to slice off the first element again because it's impossible to have this. Actually, we want to slice off 1 from the end, actually. So you can put -1. And why? The reason is we want the last element doesn't have element after it, so we can't get a pair of elements from it. Okay, so we want to check if the pair of elements has the same sign. And there's a neat little trick we can use, because we can put for if element times I, L, I, is greater than 0. And why is this the case? We want to remember that what our multiplication rules. So if we have a positive number and we multiply it by a positive number, we get a positive number. If we have a negative number multiplied by a positive, we get a negative, negative, positive. So if both elements have the same sign, which is these things here, we can see that they're positive. So we actually just want to check if we multiply the elements together, if the output is positive. If it's positive, then we just print the element, and actually, sorry, this should be I plus 1. And we want to print this, the element after it, so it's matching pair. And the last thing we want to do is we want to break this for statement. So what a break does is it means that we stop executing the for statement and just continue. So if we hit this break, it's like the brakes on a car, we'll just stop looping over it. And the last thing is we want to check if there is no such pair, we want to print 0. And how do we do that? We need to use the else in the for statement. So what the else does is if the for statement finishes looping perfectly, then the else, whatever's here, will execute. But if it's broken, like here, we're going to break it, because we found a pair, then it won't execute what's here. If the for loop executes perfectly in our case, it means that there are no pairs with the same sign, so we want to print 0. If we run this code, let's copy this example input, and as you can see, it finds the correct output. But how about if there's no pairs? Let's check that. As you can see, it still prints 0 because it runs this else statement because the for loop executes perfectly. So if we submit our code, you can see that the code has executed perfectly. So that will be all for this speedrun, and I hope to see you next time in our next speedrun where we will be continuing to explore the lists problems.